Hello, everyone. Good afternoon or good evening for the people who have joined to the stream today. So let us start 1 or 2 minutes early so that we can do the sound check and see who we have on the room. So if this is the first time on the stream, go ahead and introduce yourself to our community. You can say hi in the chat window and welcome to our stream. And if you can hear me, can you just give me a shout out in the stream chat? You can just say hi, or I can hear you loud and clear so that we can start on time. So we have one person. I appreciate you, Mr. Sandeep. Okay, there are a few people coming in. Basu, Lakshmi, Krishna, fantastic. So I assume you can hear you as well. Yeah, thank you. Thanks for the confirmation. I can see the message saying that you can hear me. Fantastic. So we still are early by a minute, so let us wait for a minute for other people to come and join. Then we can go ahead and get started. Before we start, I would like to know who we have on the room. Are you somebody who is already using AWS? You are working in AWS every single day? If you are, then just go ahead and say yes or one in the chat so I can see it, so that we will know what kind of depth that we need to talk about when we are going into the session itself. How, Sandeep? Thank you. This session is predominantly, yes, one of the topics that was requested for my stream last week. So we do hear on feedback and then we try to work on it. If it is aligning with our goals, we definitely go ahead and do that. Okay, there's at least 3-4 people who are already working in AWS, and Lakshmi Prasanna is learning AWS, not a problem. We have a mix of everything. As long as you know basics or foundational services or compute, it should be fine. Mr. Jogendra also says he's working on AWS. So it's time here. So let us go ahead and get started. Once again, thank you for joining this session on API security, where we are going to talk about threat mitigation, DDoS attack mitigation, and rate limiting and throttling. So welcome to our stream. And we are going to continue on the series where we are talking about API security. Last week, we did something similar where we focused on securing your APIs by putting it in a private endpoint. As a continuation, we are going to take it to the next level where we can stop flooding of your API, something like a DDoS flood or an HTTP flood, or somebody trying to degrade your services. So that is what in store today. So a bit about me here. So if you have been new to our channel, or if you have never come across me, or if you never heard me, so just a quick introduction about me here. I'm Kumar, I'm a solutions architect, and I've been doing this for a very long time, almost from the mainframes or IBM Power Systems era. So I've done many things like building architectures, troubleshooting it. I have come from an ops background, then did some dirty work, fixing things. And in my free time, I make some videos and upload them to YouTube. Quite a lot of them are predominantly on the AWS side. Some are in automation, some are in security. I'm welcoming you to go ahead and check them out. And they all will be in Valaxy's channel. And I have also created a couple of structured courses. You can go ahead and check them. The links must be there in the description of this video, where I talk about the automation and security side of things, which are my passion. And finally, most of the code that you see today and all the work that I have done some time back, if it is possible, I have open sourced them under my GitHub handle of Miztiik. So that's about me. Moving forward, let us talk a bit about what is the session in store for today. So our session today is the first thing is what is the level of depth that we are going to deal with. So I would say today's session is somewhat at intermediate level, somewhat above beginner and less than an expert. We're definitely not in an expert or advanced. So you need to understand what is an AWS cloud, what is an API. We will cover a little bit of basics, but not too much in depth. So if you have already AWS knowledge, fantastic. If you don't have and you're still interested to learn, then I would really recommend you to sit and listen so that we can learn something new here. So the topics mainly is around API gateway, and then security around API gateway, deploying a Lambda function. Basically, we are going to use an REST API where a Lambda function is going to give us an hello message, and we'll try to protect these two resources using an web application firewall. And all of this is wrapped into an automation framework called as Cloud Development Kit. We will talk about that later, but basically think of it as CloudFormation for deploying this entire stacks. So during this session, if you have any question, go ahead and use the hash question. We need the hash as well as the question as a prefix for your question. Likewise, if you have a suggestion for next video or a next stream or how we want to do it better, then use the hash suggestions in your chat so that we can easily pick it up and our moderator can work with you guys. So that is about the session. And if you want to do it along with me while you're watching this session, pretty much all of the code is automated, so you should be able to follow along with me. The code for this demo should be in GitHub, and the link is also in the description of the video. If you scroll down to the bottom, you should be able to find the code for this demo. So let's begin here. What is an API? Fundamental question. So you can think of an API as a contract between the service provider and the clients. It can be a web client or a mobile client, where the client says, I'm going to send you a request of a certain format, and the service provider will say, this is the way I'm going to respond to it. So both of them does not know whether it is what is the back behind each of those services. Like, I don't care about, as a service provider, I don't care about whether the client is going to be a mobile device or a tablet or a desktop or another server. Likewise, as a client, I don't worry whether the service provider is running a Java stack or a PHP stack or a Python stack. It can be anything. So basically the contract is, I send you a request, you process that request, send me a response back. So this is what an API or an application programmable interface is defined as. So in short, it looks like this. You have a client which sends a request to your API server, and the API server will forward that request to your web server, and the web server may or may not talk to a database depending upon what kind of API you are writing. So this is the basic construct of an API. If you want to deploy this in AWS, so instead of a database, I will use something like an DynamoDB. You can use RDS also, or any SQL database, nothing wrong. But just for an example of a serverless architecture, we are going to consider here DynamoDB. And for a web application server, we are going to use an event-driven architecture. So I'm going to use a Lambda function. And when we are talking about API servers, it's basically API gateway that we are going to use. And for people who might not know what is an API gateway, it is a service which allows you to manage multiple APIs from a single place and provides you options like logging, authorization, authentication, and protections like private endpoints or rate control or API keys, different kind of things. So this is what API gateway offers for you. So let's move forward. So if we take this architecture and try to deploy it in AWS, this is how it is going to look like for you. So you have your client on the extreme left-hand side, and the request is going to hit your API gateway, and that request gets processed at the backend. It can be a Lambda or EC2 instance or Fargate. Then that request gets forwarded back to your API gateway, back to your client. So in a normal scenario, that is how it is. But what happens when your API starts getting flooded by different people from different directions? Say, for example, there is a malicious actor who wants to degrade your service. They are constantly pinging your service, but not processing anything. Instead of sending one request per second, they are sending thousands of requests per second. And they are doing it from multiple different IP addresses and doing it from multiple different regions. Then it becomes really difficult to handle that kind of and flow from your API. So this is what we want to try and avoid, or try and protect your APIs so that all users will have the same experience, whether the user is sending one request or two requests, but not like a 10,000 requests and not adding any value to your API. So we want to protect against these HTTP floods or DDoS kind of attacks on your API. So you can have multiple mechanisms. One of those mechanisms is called as throttling, or One of the mechanisms is called throttling, and another mechanism is rate control. So let us talk about throttling a bit. Throttling is nothing but saying each of my client or each of my APIs will be allowed to have 10,000 invocations per second. So if you have multiple APIs, some of them might be public facing, some of them might be private facing. So you can have a very high limit for your private ones and a very, very low limit for your public ones, so that you know your APIs are not being mistreated or abused by the world. So likewise, that is the throttling. And for rate control, it's basically on the client side. So a client is going to send me one request, I'm going to allow that. If the client is going to send me 10 requests per second, I'm going to allow that. But if the client is going to send me 10,000 requests per second, then I'm going to get alarmed and want to take some action. So I can install some firewalls and make the firewall listen to all the traffic, keep account of who is calling my APIs and what IP address they're calling from, and automatically add some rules that will block those IP addresses which are sending a lot of traffic. So this is what I mean by a rate control on the client side. So you have protection on both the sides. One is on the client side, another one is a protection on the API side as well. So since APIs are the front door of your microservices, we need to protect them. That is what we established just now. So let us talk about how we can protect them. AWS Web Application Firewall is one of the best mechanisms of protecting your firewalls, because it gives you a very easy to use our deployment mechanism. It has a lot of managed rules. The last time I checked, there were about 8 vectors, if I remember correctly, that was by default allowed by WAF. In addition to that, there are some managed firewalls by third-party service providers like Fortinet. You can use their third-party firewalls inside, their rules inside your web application firewall as well. So you have these managed firewalls by Amazon, and then you have the managed rules by Amazon and the third-party rules. And you also have some custom rules, like you don't want to use any of the default rules given by Amazon. You want to write your own rules. Like for example, a rate control, because each API is different and Amazon cannot know that what is your API and what is your rate limit. Then you can write your own customized rate limits, and those rate limits may be based on the incoming IP address or maybe based on a client device. For example, you don't want somebody from a Windows device to access your API, for example, or you don't want an iOS platform to send a lot of requests to your API. So you can have different kind of headers or different kind of client devices. So you can have this customized rules and write them on your web application firewall and deploy them. And the other benefit of using a web application firewall is advanced automation. What we mean by that is, now let us say your WAF has identified some IP address or some client is misbehaving, either by sending a lot of traffic and not processing it. For example, it is just sending a request for a payload and not acknowledging the return payload. So this way you're just generating a lot of TCP connections, but your server is overwhelmed by the TCP connection, but none of those return packets are acknowledged. So this is what a typical HTTP flood will look like. Then what WAF can do is take that IP address and add it into your block list automatically, or you can also send it to your security team for further analysis. Also, you can trigger any downstream automation you want. Basically, you can send an SNS notification or trigger a Lambda function. You have a lot of those integration points available built into the web application firewall itself. So now we understood what is a web application firewall. Where can we use it? So typically you can use a WAF to protect AWS resources in these 3 touch points. One is an Amazon CloudFront. Another one is the application load balancer, and finally the more interesting part that we are going to discuss is the Amazon API gateway. So today what we are going to do is we are going to use an Amazon API gateway and try to secure it using throttling, and from the client side we are going to use an WAF and secure our API by using a rate limit. So our architecture, which we saw earlier, was something like this. We had our client, we have our API gateway server, a Lambda function on the back end, And once we deploy our WAF, this is how our architecture will look like. So you will have a WAF which is intercepting all the traffic that is coming into our application stack and process that request and then forward it back to your API gateway. So this way you are having an additional layer of security. So this is the conceptual part of what we are going to see today. So if you are a person who likes to do and learn, this is a fantastic opportunity. As I always say, you don't have to just listen and learn. You can also do it along with me. All the instructions and all the code is available in GitHub. So you just need a developer machine, which is Linux based preferably, makes it very, very easy. And EC2 instance will also do. Quite a lot of people who have tested this automation has used an EC2 machine for this. So enough of talking, let us go ahead and start doing our demo now. So let me switch my screen to my GitHub article so that we can walk through what is getting built and how we can deploy it in our account. So this is my GitHub. So let me just switch to GitHub now. So this link is already there in the description of this video. If not, I'm just going to add it into the chat window also so that you can go ahead and check it. You can fork it and then start using it right away, or you can do it later as well. So in this stack, what we are going to do is it's a very similar architecture. We just now saw the theory part. So I have broken this architecture into 4 different stacks. What I mean by a stack is in CloudFormation, a set of resources. So first, what we are going to do is we are going to deploy an API without an WAF. We are going to call that, I think I have named it as something like, these are going to be the 5 different stacks. We are going to call the first one as an unthrottled API. Basically, this API will not have any protection at all. It will not have throttling. It will not have a WAF to protect it. And we will also deploy another API, completely separate one, which will have throttling and which will also can be attached to an WAF. So this second stack that you see here will deploy an API with throttling enabled, and when we deploy this WAF stack, it automatically goes ahead and protects this API called as a secure throttled API. And both of them are public endpoints, so we should be able to test it from our browser. I should be able to give it to you guys, and even if you have a Linux machine and have some load generator like Apache Workbench or Artillery or Siege or any kind of a tool that can throw a lot of HTTP traffic, I would highly recommend you to go ahead and try it and attack this API and see how the API responds. So the first one should be able to accept all the requests until the API gateway default throttling limits kicks in. But for the second one, I have kept a very, very, very modest limit. For example, if I scroll down somewhere here, I have mentioned the limits as well. You can see here that the throttling, the rate throttle limit is 10 requests per second, and it can burst up to 100 requests per second. So if a particular IP address is going to send more than 1 or 2, it is going to grow. Like for example, up to 10 it will be handling, and after 10 it starts bursting, and the burst limit is also has a ceiling of 100. Likewise, the lambda function, which is at the back end, is also been set to a limit of 100, so it matches with the burst limit. So any request that is going to come beyond this 100, let's say that 120 requests are coming, they are going to be blocked automatically, and you will get an I think you will get a 403 error because the request cannot be handled. So this is what is going to happen. So let us start building this. By the way, I have already cloned this repository. That is step 2. You can see here there's a cloning the repository and building the dev environment. I've already done this step to save time, and what we are going to do is we are going to start at step 4, which is deploying the application. So let me take you to my Visual Studio Code. If you are a person familiar with Visual Studio Code, or if you're a person familiar with any other IDE which you are comfortable using, go ahead and use them. It should not be a problem. You just need a Linux machine. I'm using my own dev environment here. I have cloned it, and if I do a cdk ls here, before I go ahead and start deploying things, can you see my screen? Is the terminal visible? Just a quick confirmation in the chat. apparently my CDK stack seems to be very, very slow. So just a quick confirmation. And before also deploying, starting to deploy the stacks, what I will do is I will take you to my CloudForm. I will take you to my AWS console and show you what resources are there and what resources are going to get built. So let me take you back to my browser. So I have already kept my CloudFormation service open. You can see here, as of now, I have only 2 stacks. Let us ignore those 2 stacks. That is for some other testing, it is always there. We will see some more stacks like unthrottled API, secure throttled API, but WAF stacks, and all those things will be getting built. And if I take you, apparently I seem to have logged out. So let us wait for API to come online. You can see here there is only one API right now, which is Campaigns API, which is part of this campaign backend stack that is there, but we will be building 2 more APIs on top of this. And if I take you to my WAF, and remember I'm going to use this in Virginia region, you can technically should be able to deploy it in other regions. I have tested it in Virginia and it works fantastically fine. And you should be able to take the same concept and the same stacks and should be able to deploy it in other regions. And in my opinion, it should work as it is. If not, just go ahead and raise a GitHub issue and I'll have a look into that. So if I go to my web ACLs under WAF, and there are no web ACLs right now, and likewise I'm going to build another EC2 instance just to generate load on my APIs. So we are going to install some tools, and all the commands for installing the tools and everything are there in the GitHub. So we will build a new EC2 instance ground up and install the tools and start attacking our API and see if my EC2 instance IP address is getting blocked by my web application firewall. So that is the context on what resources are already there. So there is no magic here. Everything is going to be built ground up. So let us go back to our Visual Studio Code and start deploying. So the one thing I wanted to check is, the terminal is visible or not. I think people have already answered it. So I'm just going to assume that the terminal was visible and the font size is good enough. So when you do a CDK ls, what basically happens is it's just going to list all the stacks that are in my folder. So I'm going to do a deploy for the first stack and see what happens. So I want to deploy this unthrottled API, and I think it takes about a couple of minutes for this stack to get deployed. Basically, there is an API gateway and a Lambda function that gets deployed. These are the 2 resources. And once it is successfully deployed, we should be able to get the public endpoint on our screen and we should be able to access it. All of us should be able to access it. And remember, this is not an webinar about how to write Lambda functions. So the Lambda function is pretty much basic. It just says, hi, how are you? That's it. And then it probably gives you a timestamp saying this is the time here, so that whenever you refresh it, you should be able to see a new timestamp. I think that's how I've written the Lambda function. But if there is an interest on how to write a REST API with a different kind of a querying mechanism, then we can look into that later. So while this is getting deployed, I'm going to look at the chat. So far I've not checked it. If there is any questions, I can answer them. And remember, as I said in the beginning, if you have a question, go ahead and use the hash questions so that the screen that I have in front of me will be able to highlight that. So we got our stack deployed. So you can see here, this is the endpoint, unthrottled API URL. So I'm just going to copy this and put it into the chat window for you guys. And can you guys go ahead and check it and confirm to me that you are able to access it? And let me also go to my browser window and check it out. So when I open it, hopefully, fingers crossed, demos are always interesting. So you can see here, it is a very, very simple message, says, hello, mystical world. The time is here, how about there? So this is the Lambda function running an US East 1, and it takes the time from there, and then it shows it. I think it is datetime in UTC format. And if you might be most probably getting an text message which looks very much like this. Since I have used a browser plugin, it renders the JSON in the nice format so that it is much easier and legible. So let me just increase the font a little bit more. Okay, that should be good enough. So this is a public API, and if I go ahead and hit it 10,000 times until my API gateway's throttling limit, which is set at default, it should be able to try and answer it. And while it is answering it, my latency will increase for all the users. So let me just walk you through what has happened here. So this is my unthrottled API, and if I go inside it, and I think I always forget where exactly the settings are sometimes. So let me just click around a little bit. I think it is under resources. Okay, come on. I'm so much doing it with CloudFormation now. I'm struggling with GUI. Come on. Looks like my screen is slightly frozen, so just to give me a moment. This live streaming and clicking on too many resources, sometimes my browser gets stuck. So meanwhile, can somebody check if you can access the request, access the URL? And if you have a Linux instance, an Apache Workbench, or any kind of a load generation tool, I would highly request you to go ahead and attack that URL so we can see the hits on the dashboard. I'm just waiting for my screen to unfreeze, so just give me one moment, guys. I'm just trying to fix that. We still have a couple of more stacks to deploy. One is the throttled API, and then we need to secure it with our WAF. And then, so you can see here, I just clicked on refresh on my screen, and it is still on a white page for API gateway. So I'm just waiting for my page to refresh. Unfortunately, there seems to be a problem with my browser. So let me just quickly fix that. Okay, there is some progress. Fantastic. So you can see here, I managed to refresh my screen and got it working. Under stages, if you go under stages and go ahead and click on the method, because there is only one resource here, we should be able to find everything here. So under the settings section of your API, under stages, you have something called as throttling, and it is the default setting. We have not changed anything, because if you remember, I mentioned it as an unthrottled. So this is the maximum limit applied by Amazon by default. You can see here your current account level throttling is 10,000, and it is mentioned here, and with a burst limit of 5,000. So this is what this means is this particular API has an capacity to serve 10,000 requests per second, and it can burst up to 15,000 per second if necessary, and it will not grow beyond that. So it's just going to stay flat at 15,000, and any other request beyond that 15,000 is going to get blocked, and you are going to have 403s or 429s depending upon where you are at the request. So if you go to my dashboards, you can see here right now all my requests, there are some 500s. I'm not sure why, but that is a very, very small number. There is only probably just like one error, probably an blip in the deployment scenario, I think. So right now we are not having any errors, but once we start throwing some traffic and we start hitting the limits, we should be able to see some 400 errors in a short while, because we are going to create an server which is going to throw a lot of traffic at this API. So this is the unthrottled API. What I'm going to do now is I'm going to go to my Visual Studio Code and start deploying my secure throttled API as well. So let us get over there, and if you remember, it was cdk ls, and I'm just going to start typing now itself. And if I remember correctly, it is secure throttled API. So I'm just going to wait for the listing to happen, and then I'll press enter, so it starts deploying the other stack as well. So yeah, secure throttled API, and then enter. So this is what this is going to do, is it is going to be taking the very similar configuration like the previous stack, but only thing is, instead of the default limits, I am going to enforce a much lower limit, so that I have a space for other APIs to grow. In my opinion, never you leave your APIs at the default, because if one of your API is getting attacked and it is serving a lot of requests, it is going to degrade the service performance for other APIs also in your account. So that is why you should not never leave it at default. Although the default limits are very high, you might think that why go and change it, but when you have a problem, it becomes very difficult to troubleshoot why your API is behaving incorrectly, whereas some other API is consuming all the requests and your legitimate API is suffering because of that. So that is the reason you should not leave it at default and set a hard limit or limit on your configurations, so that you can change it anytime. So this is getting deployed. This will also have a public endpoint once this stack is completed, and I will add that in the chat so that you can go ahead and check it out. So do we have any question while this is happening? Okay, looks like this is also done. So I'm just going to copy this and put it into the chat now. And this is also going to give you a very similar response. There is not going to be any change in the response, but only thing is it is going to have some limits. So let me go to my browser now and just go ahead and add this, and we should be able to get a response here also. So far good, but let me walk you through my API gateway. So if I go to my API gateway, there should be another API deployed now. So here you can see here there's a secure throttled API, and let me open that. And for throttling limits, okay, let me duplicate this window so that we will have both the throttled and unthrottled one. So we are under the secure one, and let me go to stages. And let me click on this one. Come on. Yep, you can see here this is the point I was talking about. So if I go back to my APIs for unthrottled, we can just have both the windows side by side and compare them. So unthrottled, and go to stages. Come on here. Yeah, so this window is having the unthrottled limits. This here the default limits 10,000 and 5,000, and this is the one which is protected, and these limits are configurable. So I have set a limit of 10 and 100. Likewise, my Lambda function behind this API is also having an concurrency of 100 request 100, so that means that it can go ahead and invoke 100 times per second, and anything beyond that will be obviously throwing an error. And let me just keep the dashboard open so that we should be able to see some responses. So right now you can see here there are no 400 errors or 500 errors, and once we started deploying our WAF and load generator stacks, we should be seeing some errors here. And we also can do a curl test once we have deployed the other two stacks. So let us begin the protection by using the Web Application Firewall. So going back to our Visual Studio Code, and I'm going to deploy CDK deploy WAF-stack. So this is going to create an Web Application Firewall and attach the secure throttled API to the Web Application Firewall, and add and rate limit saying that if the request is more than 100 or 200 per second, if the request is 100 per 5-minute period, then go ahead and block that IP address. So WAF works on a 5-minute block period. So you can set a limit of how many requests that you want to receive within a 5-minute period. Then WAF will look at the request, count it, and then go ahead and allow or block depending upon the configuration. So this is going to get deployed, and if I remember correctly, this stack takes about 4 or 5 minutes also. So I'm going to look at the chat right now. So you can see here there are some resources that are getting built, and the Web ACL association is happening, and we got our Web Application Firewall also as deployed. So let us go back to our console. So if I go to my WAF, let me refresh my screen. And remember, WAFs have a regional deployment and global deployments also. So this is going to be in Virginia region. So keep that in mind. So if you want a regional, whichever region you're deploying, then you need to go and choose the drop-down appropriately. So you have different regions, go ahead and choose them. And our API WAF has been deployed. So this is the one which is called as a API Sentry ACL WAF stack. And under this, you have different ways of configuring rules. Let me just wait for it to open. So if I go to rules, meanwhile, so it's still loading. So you can see here there is a default rule, not a default rule. As part of the CloudFormation stack, I have created a rule, and it says that limit requests per second to 133. So basically what this means is within a given 5-minute period, if there are more than 133 requests, that particular IP address will be blocked by the WAF. And given in any subsequent 5-minute period, if the request is lower than 133 from that particular IP address, it will be automatically unblocked. So you don't have to do anything. So you can see here the default action as block here. And if you remember, I spoke about the other rules, whether managed rules or custom rules. So you have this option here under managed rules. You have all those third-party rules I spoke about. You can see here the Fortinet and some other companies, and some of them are managed. So you can just go ahead and it's all click button enabling. You just need to say add this to WAF and then click on add rules. Automatically this rule gets applied to your web application firewall. Pretty much very, very easy to configure. Likewise, you can go ahead and add your own rules, custom rules. So you can see here there is an IP based ruling. So you can allow certain IP addresses and block all other IP addresses, or you can do a rule builder where you just choose what type of rule you want, whether it's a rate based rule or an agent based or browser based or client based. So you have a lot of flexibility in writing your own rules also. So right now we don't have any request. I think our protected resource, if any of you guys have sent some request, it will start showing here in this section. There are no results to deploy because it is just deployed. It will take 5 minutes at least to start showing the allow request as well. So you can see here we should be able to later go and filter based on this particular rule and see what request has been allowed or denied by this particular rule. So what we have done so far is we have deployed two APIs. One is Throttle API and another one is an secure, first one is an unthrottled API. Second one is a secure throttled API, and we also have an WAF to protect it. So what we are going to do next is we are going to deploy an EC2 instance just to generate a lot of traffic, let us say about 3000 or 2000 requests per second against our server. So we need a Linux machine to generate an IP address, generate that kind of load, and we need a public IP address so that we can verify whether that public IP address is getting blocked or not. So I'm going to use an EC2 instance for that. So for that as well, we are going to go back to our Visual Studio Code and started deploying our load generator stack. So if I remember correctly, I named it as a Miztiik artillery load generator. What we are going to do is we are going to use an open source tool called as Artillery. It is based on Node.js. You can use something like Locust or any other tool that you are familiar with. But in this case, I decided to go with Artillery. Oh, I made an error. CDK deploy. This is the one I wanted to pick. And this stack has a dependency on this. There is a VPC stack, so it automatically will deploy both my VPC as well as my EC2 instance. And once again, this EC2 instance is also not region specific, so it should work in any region of your choice. The AMI will get picked up dynamically from your Amazon account. So you can see here it is deploying the VPC stack, and once this VPC is deployed, it will automatically create an EC2 instance, and we should be able to log in with the SSM agent. So no keys involved. So this is going to take some time, at least 5 to 10 minutes, because these resources are intensive. And I'm going to have a look at the chat to see if we have anybody having any questions. So far I have not seen any question pop up on my screen, and meanwhile I'm making this request again. If you have any kind of mechanism to send a lot of requests, because the minimum request is around 100 or 200, 100 I think in WAF. So if you can generate more than 100 requests, we can see if your IP address is getting blocked, and we can have that on the WAF console show up. So if you're watching my screen, you should be able to see the VPC stack is completed. It is starting to build the artillery load generator. So once this stack is completed, we need to run some commands to install the artillery tool itself. So this is the command. You can see here, I'm just going to blindly just copy paste this commands, and it should work. So basically, just to walk you through, what we are going to do here is we are installing, I'm sorry. I just clicked on the edit mode. Okay, what we are doing is we are installing bash, and then after bash we are installing node. We are downloading the bash package for node, and then we are installing node, and then after that we are saying npm install artillery. And once we have the artillery installed, we are going to create 2 log files to store all the load generation metrics, and we are just changing the permission of those log files. And if you're interested in, if you're somebody who is interested in automation, I have built some nice plugins on the back side of this EC2 instance. all this information on these log files are sent to your CloudWatch log group as well automatically. You don't have to do anything. These two custom generated log files also is getting sent there. You can go ahead and have a look how you can send information from your EC2 instance to CloudWatch and build some metrics on top of that. So while this is getting deployed, again, quick look in the chat window. I see a question there: how to improve state machine error logging? Good question, but since it is out of context, I'm going to park it for some other time, Mr. Suraj, probably for the end of the session. If you are having any question what is being done right now, then we will handle it. For anything out of context, I will take them at the end of the session. So this is one thing that is always takes time, creating an instance profile. Is basically an IAM role that can be attached to an EC2 instance. It takes about a couple of minutes even if you do it on the console. So while this is getting built, let us go to our CloudFormation or EC2 console and see what is the status of the instance. So we have our EC2 instance here. I am in Virginia. Refresh my screen. I should see one instance coming up here. Okay, its status is running. Assuming my SSM agent is already online. The interesting thing is, as I called out in the last live stream or webinar as well, this instance also does not have any SSH keys. So you can see here the key pair name is empty, but we are going to use the SSM connection manager to log into that. And let us make a note of this IP address. This is what is going to be blocked by my WAF in a short while. So let us connect to this. Go to session manager. Okay, my agent is online, and I think we might have to increase the font size here because the terminal is usually very small. So I'm going to jump into a bash shell because the default shell is sh. We don't want that. I'm going to have a bash shell. And if you remember, sometime back I showed the set of commands that we need to run to install bash. Need to install artillery. So that is what I'm going to run. It is all in my GitHub article. So I'm just going to go ahead and copy them and run them here. So I'm just going to copy all of this and put it into my server. So it is installing artillery now, and once artillery is installed, we need to collect our throttled and unthrottled URLs. So we have completed the log files. We have set the ownership of our log files, because you see here I am running the terminal as SSM user. So I'm just changing the ownership of the file also to SSM user, so that artillery can read and write to that log file. So you can see here we are done up to this part, and we need the Throttle API URL and secure API URL. So this can be found in our CloudFormation console. So we go to Throttle API URL under output section. This was the same thing that I pasted to you guys as well. Oh, let me just copy this properly. So this is unthrottled API URL. So let us go to systems manager, unthrottled API URL equal to this value. Likewise, I'm going to add the secure API URL. And this can also be found in the CloudFormation. So we are in the unthrottled stack. Let us go to our secure throttled API stack. Under outputs, we should be able to find it. Okay, since we zoomed out in the other window, this is also looking horrible, but this is the URL I'm looking for. So let me paste it here. Okay, we have set the environment variables. So all that is required is generating the load. So the generating the load is, I'm going to talk a little bit here. You can see here, this is the command artillery. And what we are going to do is we are going to run this request for 310 seconds. So basically, if you remember, I spoke about WAF needing 5 minutes for doing some checks. For example, if the request is more than 133 for a 5-minute period or 300 seconds, then it will start getting into action. So I'm going to bombard my API for 310 seconds, so it is slightly above the 5-minute average, and we are going to have 5 users sending one request. So this is going to happen for 5 minutes, so we are typically going to send about 1500 requests, something like that. So I'm just going to copy both of them, and let us say copy this. So basically, I'm going to send request for my throttled as well as my unthrottled at the same time from my EC2 instance. And after some time, it will give you a summary. So this is going to run for 5 minutes. Until then, I can happily answer some questions if you have, and go ahead and put them. Then we can go ahead and check it out. And one last thing is we need curl command, but anyway, I think we can do the same thing from this terminal also. I will show it from my desktop as well if needed. So let us go to the dashboards of both the APIs. I'm just going to shrink it a little bit. Go to dashboards of this is the unthrottled one, and this is the throttled. So I'm just going to say today, so that we are focusing only on today, and I'm going to do that for both the APIs. So right now my APIs are getting bombarded by my load generation stack, and we should be getting a lot of information in a short while here. So I'm going to leave it as it is, and let me also show you the CloudWatch part where all the logging information are happening. I'm going to push it all the way here. So my EC2 instance must be still throwing some logs here. Yeah, it is still throwing traffic at it. So if I go to my log groups, it seems to be terribly slow. Looks like streaming and doing something does not go very well today. But in any case, since our EC2 instance is throwing the traffic, the latency metrics should not be impacted. This is just my screen having some slow internet issues. Okay, probably I should have started a timer so that we can count how long the 5-minute window is gone. So meanwhile, let me just come here. Okay, there is something is happening. You can see here, guys, this is my web application firewall. Let me just choose the 1 hour period. You can see here initially there was like what about 4 or 5 requests, about 4 requests that you can see here, and as you can see in the pop-up, the rate limit blocked request is nothing. There is no blocked request, and slowly my request has increased to 200 or plus 200, and in a short while we will start seeing the rule kick in, and then it will start blocking IP addresses. So we should be able to see an amber or orange color dot also on the screen in a short while. because this is just 200 requests. There is another 1,000 requests that are pending to come in and be processed by WAF. So while this is, we need to wait for 5 minutes for the request to start showing up, because we have not even finished throwing the traffic here. So let us go back to CloudWatch here. Oh, apparently there seems to be a problem, I guess. Let me just refresh. But anyway, CloudWatch was not something that I was intending to show, but apparently there seems to be some problem. I'm just going to press a couple of enter to make sure that once it is completed, we will know whether it is completed or not. Let me go to my API gateway. So I just refreshed my API gateway page, and if you can bring your attention here, we are in the secure Throttle API. You can see here my 400 errors. This is typically 429 errors if I remember correctly, or 403 errors. Automatically my throttling has kicked in and my rate limits have kicked in, and instead of answering to all the spam requests, automatically my API gateway is blocking those requests, and my performance is maintained for all other requests. So all legitimate requests will have very low latency, whereas if I go to my unthrottled API or unprotected API, we will see a smaller number of errors. So this is before I refresh my screen. You can see here there are no errors, 400 and 500, but here we will see more 500 errors. Because it is 15,000 and I'm sending only about 1,000 requests, it should try and meet all the requests. Let us see what happened. So you can see here it has only about 60 or 60 to 70, let us say 70, 500 errors. So it has tried to answer all the 1,000 requests, although they are a DDoS kind of attack, but this API is trying to answer all those requests, and the performance latency is going to take a hit for this API, and it increases the latency to all the way up to 2.5 seconds, whereas this API is still protected, and we are about like 600 seconds latency. That means that 1/3 latency. So all my other requests are being satisfied at the same time without any degradation of performance, because I'm stopping most of my spam requests here. So let us go and check our systems here. I think, yeah, this is done. And if you remember, I have the log files here, so I'm just going to show a summary of those log files. There is a command for that also built in here. I'm just going to run this so that we can quickly see a summary of what happened in both those tests. So what you see at the top is the unthrottled log summary. So we sent about 1,550 requests in total, and the minimum time it took was about 24 seconds and max is about 10 seconds. And you can see here this is a HTTP code for 200 and HTTP code 200. So let me just increase it a little bit. Hopefully that should be fine. Yeah. So HTTP code 200 means that it has tried to answer about 1,481 requests, although they are DDoS kind of attacks, and only about 69 requests have failed. Whereas when we come to the throttled secure API, it handled about 339, and it understood that or it identified about 1,200 being spam requests, and it denied them well in advance. And you can notice that the minimum request time is 12, and the median is also maintained at the same point. is here. You can see here the median has gone up to 60. Median is nothing but the midpoint of how many requests was handled at the same average. So you can go ahead and check that. So here I'm maintaining almost half the performance even though I'm under attack. So that is how you use throttling and rate control for your APIs to protect them. So the last thing I want to check in the WAF, hopefully we should be able to see our public IP address of our EC2 instance being blocked by our WAF. If you remember some time back, I said we will be seeing an amber or an orange color dot very soon. And as you can see, the WAF has identified there is a particular IP address that is sending in a lot of spam traffic, and it has identified that, and then it has blocked it. You can see here in the bottom it says blocked request. So I'm just going to remove this one and this one so we can see that particular dot alone on the screen here. So if we scroll down, okay, that is interesting. Probably I need to refresh because usually what happens is you will start seeing the IP address, that is the what is the rule that will stop the request, and what is the source IP, and which against which URL and which rule got triggered. And remember, this is iterated over a 5-minute period, so it takes a few minutes for the text to come online, that is the results to come online. So what I'm going to do is I'm going to look at the chat and see if there are any questions, and I will answer them, and then we can come back to our WAF and see whether this dashboard is updated with the status of what request is blocked or attacked, allowed. So while I'm doing that, I'm just going to put in our Q&A part of the slide. So we should be able to have a Q&A section. So this is the time if you want to have any questions, I'm happy to answer them for you. And if there is out of context also, I'm happy to take them. And just a request to everybody, we are almost at the close 2:30, but if you are having any questions, just go ahead and use the hash question. As you can see on the screen, I would like to have the hash as well as the question so that my filter will pick it up. So there is a question from Mr. Suraj, how to improve state machine error logging. Would like to have a clear step function error reporting in order to reduce time spent finding root cause of incidents. To be honest, I am not sure what is the question here. If you're looking for logging your state machine errors into CloudWatch, it already does that. You don't have to do anything different. But apart from that, I'm not sure what you are asking me there. If you can be more specific, because it, to my knowledge, step function logs are already in CloudWatch, and you can also write your Lambda functions also to send your information to CloudWatch. Or maybe I'm wrong. Step functions are on the step function console. I think that I recently saw there is an integration for that. I might be wrong here. If I'm wrong, please do correct me. So what I'm showing now is the WAF. Apparently the screen is updated with the request. So you can see here, these are all the requests that are allowed. But if I go ahead and choose this particular rule, and you can see here it has blocked this particular IP address. So this IP address is nothing but our EC2 instance IP address. This is the public address. So if you do a curl for our secure API URL right now, it should give an 403 error, I think. So let me try it. If we are within the same block period of 5 minutes, we should be having an problem. So secure underscore API underscore URL. I think that is what the variable name I gave. Okay, we are out of the block period of 5 minutes, so automatically we have been unblocked right now. Otherwise, if you do it within those 5-minute block period, it will give me an error of 403, or yeah, you can see here it is the 403 error that we should be getting in 403. So if you are doing it at your home, just try to do it within those 5-minute period, then you will be getting an message saying your request has been blocked. So that is pretty much all that I had to share today, and I'm happy to answer questions. We are already 3 minutes beyond our scheduled time. I can happily extend for another 5-10 minutes and answer questions. So while we are doing it, I'm going to quickly check whether step function logging is sent to CloudWatch. Yeah, step function metrics can be sent to CloudWatch. I just now checked the documentation. It seems to be possible. So that is obviously there are certain metrics that are already reported, and if you are using Lambda functions for running tasks, then those Lambda functions should be able to send information to your CloudWatch log groups. So there is another question about canaries. Is that right? Synthetics and canaries. So again, yeah, it's a straightforward configuration for canaries. If you are doing some health checks or site monitoring, then you can use canaries. They make a fantastic combination. So what is your question there? You seem to have answered there. Any specific examples? Yeah, the default example is the same, right? If you have a website and you want to check whether the website is on or off, then you can use your canaries and synthetics to check. But there is a Lambda quick start also, which does that for you. So depending upon how you want to do it, whether you want to do it in CloudWatch synthetics or you want to use Lambda functions, up to you. So I will wait for a minute or two. If there are no other questions coming up, then we can wind up. Apparently today doesn't seem to be the most interesting thing. Very quiet audience. Either I made it very clear or confused everybody. So next week we will take a little bit slightly different direction in API gateway deep dive sections. What we will see is something about securing APIs in a different way. There are a couple of more topics that we can talk about when we are talking about API gateways. And once we cover that, then we can look at some other topics. So meanwhile, a request for all of you that are there, if you have a suggestion or a recommendation or a feedback, put it there in the comment section. For example, you want to change the session into a different date or a different time, or if you have a different topic that is in mind that you want to talk about. We are not saying that what you are saying will be taken into action, but your suggestions will be a great influencer in our decisions that we are making. So we look into the feedback and fit it into our roadmap, and we try to accommodate most of our audiences. So you can put it in the chat window or put it in the comment section, or you can reach out to us in any of our social media handles, either in LinkedIn or Facebook or Telegram or in YouTube. We have people who can read them and respond to you and take into action. So one last question before I drop off for the day. From this is from Kavita Reddy, and the question is, we can request or block specific requesting. That is what I think I showed here. So we have shown how to dynamically block an request that is coming from a particular IP address. If you want, you can use a custom rule also and use the IP set to block or deny. So it is possible, and you can also do something similar in API gateway resource policy. We showed that in the private webinar, the last week's webinar, where we created a private API with a resource policy. There also you can set a condition for saying allow or deny based on IP addresses. So that is also possible. So you have two options. So another question, I think it's suggestion, most probably any suggestions on multi-applications into a single ECS cluster. Well, there are very few use cases for that. So most probably not. We can show one application, but there is not much value in showing multiple applications onto the same ECS cluster unless the question is around the governance of multiple applications. Because whether you deploy 1 container, 10 containers, it's ECS that is going to take care of it. So we are at 10 minutes past our usual schedule. Thank you very much for joining on a Friday. I will see you again on the next webinar on API security. Thank you once again for joining, and have a pleasant weekend.